This is Stewarts Theorem, one of the more obscure math team theorems. It's for a Sevian segment. So I have drawn a triangle here. I'm going to add a Sevian segment, vertex to anywhere. Doesn't have to be an angle bisector or a median, just has to be a segment, Sevian segment. And you can find lengths in the triangle using Stewarts Theorem and some of the given lengths of sides. Stewarts Theorem, like I said, is kind of an obscure thing. And it's difficult to remember, and so I've made up a little trick, I guess, from the Russian Navy. I hardly ever see this on math teams, so I'm going to use the letters from the word hardly. So I'm going to put the H in for the length of this side of the triangle. A is going to represent the length of the segment from vertex to where the Sevian segment hits. R is going to be the other side, length of the segment. D is going to be the side of the triangle. L is going to be the Sevian segment length. And Y is going to represent the length of the whole side of the triangle. Basically, A plus R is going to equal Y. So I've used the word hardly to do this, and so we're going to make an equation, and what it's going to look like is this. Now, before you look at this and go, I'm never going to be able to remember this, try to make words out of it and try to give you some kind of visual here. Let me get my red pen going. So I've got HRH. That's going to be the word her. But if you look at visually, I've got the side of the triangle, opposite segment, back to side of the triangle. So HRH is going to be the word her. And then I've got dad, plus dad. And I've got side of the triangle, this portion again, side of the triangle. So it kind of bounces back and forth like the H and the R did. Now that product will equal LYL, L-Y-L, and that's the segment, side, segment. Notice how it bounces back and forth again. And then I've got the word ray, and that's the three portions of the bottom side here, the R, the A, and then the whole side Y. So you multiply H times R times H, then D times A times D, L times Y times L, and R times A times Y. So to try to help you to remember the theorem here, I've got the word hardly spelled out, and then kind of a sentence here, her dad is little Ray. This is supposed to be like little, L-Y-L, like little. Her dad is little Ray. The next slide, I'm going to throw some numbers in and we'll do some calculations. So I've thrown in these distances, lengths of the segments, and we're going to do some calculations. So her, 10 times 12 times 10 plus dad, which is 15 times 8 times 15 equals LYL, L times 20 back to the x, so x times 20 times x, and then ray is 8 times 12 times 20. Okay, so her dad, little Ray. It's better than other ones I've seen, trust me. So there's the product of the numbers, the asterisks represent product. And just run through the arithmetic, multiply, combine similar terms, divide, and square root and simplify. And that's the length of the Sevian segment. Stewarts Theorem, hardly ever seen.